Welcome developers. This video I will be walking you through getting started with Postgresql, mysql. They're very similar. So I think learning this stuff is important, especially when you're learning back-end software development, because it's something that you'll need to know, and you'll need to know how to create tables, create databases, drop databases, insert new data, and you're going to have to learn getting creative, making queries. You're going to have to learn the whole process of dealing with data and how to sort it and how to create relationships, schemas, many different tables. So I think to get started, one good thing to do is to deal with a data set, preferably a large data set that you can generate from a site such as Mockito, which will help you create mock data sets. And it's all, you can exploit the AI they have here. You have a tool here to create your columns automatically with the help of the AI they have, or you could just by hand create your table here. So I'm going to walk through making our first mock data set, and then on that mock data set we'll walk through some functions, some queries that you can do with PostgreSQL. So it's quite traditional that when you're creating a table, you have like an ID column that can be a primary key. But I think I'm going to try not having an ID column here, because I'm going to try to show something a little bit extra here. We're going to create a column called plant name. We've got the plant name and the family name. So let's go with store. Maybe we could just go with store name, right? And we're going to give it some possible values. So what you do is you click custom list, and we're going to give it different values of, let's say, store A, store B, store C, store D. Let's go price. So maybe we could have a price of the plant, right? We could say number. And then here, this is important. We want 0 decimals. So that's going to tell us that we want integers. And we're going to say the price is going to be somewhere between $5 and, let's say, $75. And we're going to call this table called sales, or plant sales. And let's get a set of 30 lines. And let's preview what the create table would look like if I did that. Okay, so we're going to create a table called plant sales, plant name, store name, and these are the mock prices. They look like integers here. And I think that's generally the idea we have. So we're going to, I don't think I'm going to save this really. I'm just going to copy and paste this. So what you do is highlight it, copy. Then we're going to pull up our, what's called an SQL editor, our dbeaver here, which you can download. If you're using Mac, you could try the brew install. There's a brew command to install dbeaver, or you can download the Silicon chip version. So yeah, this is the dbeaver community edition. So in order to run this script that we got from Mockito, we can go to our default database in Postgres, which is Postgres. Default schema is public. We right click here, and we're going to open SQL console. Now this is where we can simply just type in a lot of different SQL commands and it'll just run it for us. I'm going to paste in all that stuff we had. And we're going to massage this a little bit. So remember I said generally tables have an ID, and we don't have an ID here. So we're going to create an ID column. ID int serial. Primary key. I'm going to highlight this all, Control Enter. Yeah, I have, see, my syntax is just bad today. Let's see how this works. Okay. We're going to run the rest of this stuff here. And then in SQL, we just created this table of data successfully. And then in order to view it, we do select star from plant sales. Okay, so we can see that at this store, store D, we sold this plant at that price. Now you see how we have so many different store names here. This is different than that store name, right? This is not simple to look at, so this is where we start getting into groupings and ordering things. So if we want to view this as the stores grouped together, we can do select star from plant sales, order by, and it's not prompting me. Okay, so that's how we can view the stores grouped together nicely looking. I should have actually added another column of like date time, right? The date time of these sales. Because if we run this again, select star from plant sales, because we had this primary key constraint, it's going to naturally order it by ID. So we see all these ordered by ID, but we don't really have much context. Ideally we'd want to see these. If we're dealing with sales, we want to see the sales ordered by date and time, right? We would want to have that option, but we don't have the option because I didn't create that column. But either way, we can do some more stuff here. So let's say we wanted to, and I'm going to write this down. So we want to see the biggest sale for each store, right? And I think we have 4 different stores, right? Store A, B, C, and D. And we want to see the biggest sale that was done. And we could say the sale was the biggest like price, right? The biggest price transaction for each store. So if we run this again, where we select by store name, right? So we went back to grouping this by store name, but now we want to see the biggest price. Now let's just try this. Let's see what happens if we just tack on price at the end here. Okay, so naturally when you do like an order by and it's landing on a number column, numeric column like this, it's going to naturally want to order it ascending, right? Lowest to highest. So maybe instead we should do order by price descending, right? descending, so we'll see the highest on top and then the lowest. Okay, so now we're seeing, right, we're seeing the top price, right? So we're seeing store B, we're seeing this price here, we're seeing store C, that's the highest price there. Store D, we have 58 here, this is the highest price. Although what we want is, we want just, since we have only 4 stores, we probably only want 4 rows of data, right? We want to see the biggest for store A, and we want to see the biggest for store B, etc. So we have to do a little bit more to get a more precise result. I think one interesting way of doing that would be to do, I think we're going to do select star, and then we'll do row number or rank. Let's try dense rank. Dense rank over yeah, partition by store name. Order by price descending from plant cells. We're going to alias, we're going to give a name to this, so we'll call it as R. So let's see what happens if we do this. If we select star and then we create a ranking for these prices coming in. So now we see store A, the biggest price is 73, and we see it has a ranking of 1. We see store B, biggest price is 75, and its ranking is 1 also. And we see that this generally worked, but we still have the problem where we want to select 1 for each store. So to do that is we can do, and with SQL we can always just indent things and it'll still work. So we're going to select star from here, actually we're not going to select star, we're going to select ID, plant name, store name, and price from this query we just made. And we have to give it an alias, just call it A. Where R equals 1. Let's run that. And there we go. We see store A, the biggest price that came in was 73. Store B, 75. So I think that's a fun way to do that kind of query. But this is stuff that you have to know for if you want to get into like the data science SQL stuff, is you have to be able to on the fly generate these data sets. And there's a nice little trick I want to do is let's just walk through creating another table, because I think it's good to get comfortable with creating these tables, right? So let's create a new table where, let's go with like username, right? Let's create a table with username and usually username, and let's say I'm trying to create a table of like let's say some entity wants usernames, wants to store like usernames and passwords and stuff, right? So let's say password. We'll do something similar to what I did before. And let's preview this again. Okay. This is generally what I had in mind. Oh, the password. I messed up the password. Yeah, we want random passwords, right? Blank 0%, minimum length 8. That's pretty cool. Okay, these are interesting passwords they're generating here. They have like weird characters in them. Okay. Alright, so I think this is what I had in mind. Okay. Yeah, this is really delicate stuff, so I'm always second guessing things sometimes. Okay, we'll copy that. Right. We'll paste that. We'll add an ID column. And then I want to add a constraint where so we're going to add a constraint of username and password have to be unique, right? So I guess we could say like I forget the exact syntax to doing this. Oh yeah, add constraint, we have to give it, yeah. Unique values on user and password, right? Add constraint this on username, password, unique. We want username and password to be unique. So let's get rid of the add word. Okay, cool. I'm going to refresh our tables here. And we see our table here called users, right? We see our constraints. So these are unique. It's a type of key, right? It's a unique key. We have a primary key. We ultimately have our table here. Alright, so now I'm going to show something here where I'm going to run. Okay, so let's say I have this first column. I want to enter this, right? Let's just enter this first column. Alright, so we successfully entered that, the first column. Or I should say the first row, right? I need to take a nap right now. Alright, so we entered our first row, username and password. Now let's see what happens if we try to enter a duplicate username and password. Because we created this constraint where username and password has to be unique, right? So let's try to run this again. And see, we run into this error, right? Now let me try running both of these. Okay, so you would think that if I run both of these, okay, it's going to throw an error here on this first line, but maybe it'll enter the data on the second row. So let's try to run both of these. Right? It still throws an error, right? So it's gonna not want to enter all this information if it runs into one error. So one thing we have to do is we have to add this statement. We have to tag it onto the end of these, which is called on conflict. username, password, do nothing, right? So this is a nice trick where since we have these constraints on the username and password column, if SQL runs into an error on this, it's just going to skip past and try going to the next line. So let's run this again. And you see it was successful. And we look at our table. We refresh. Now we have 2 rows of data. I think it's also interesting that this new row of data has an ID of 5, and I guess when it ran into the errors a couple times, since it's serialized, it incremented the ID. So the first successful entry after the first entry became an ID of 5. It's an interesting nuance with how this stuff works. So yeah, there's creative ways you could you can fix this. So all these generally I have to use VS. I wonder if I could just highlight this. No, that's not going to work. Let's just do this. I want to find all occurrences of that. I could do replace all. I don't really want to replace all. But yeah, there's different ways we can apply this to all these. I suggest using that find command. But yeah, I just wanted to show that just to show like how this stuff works. So I'm going to enter the rest of this information here. And we got our table. Let me refresh that. There's actually a way with dbeaver to actually automatically refresh, which I think is pretty cool. So in 10 seconds it should refresh this. If we just wait, right? Is it going to refresh? There you go. See, I didn't click anything. All I did was I scheduled the views of these tables to refresh every 10 seconds. So now we see our users table. And so I think it's important to add this on the end of these insert into statements, because if you're dealing with Mockito or even just a normal application that's inserting data, you might want to skip over errors you run into, right? So things work more smoothly. So then it would be good to add this on conflict. On conflict of these columns you have constraints on, just skip to the next statement. So let's try doing another, let's get comfortable again with doing these SQL queries. So just run select star from users. Okay. And if we want to see all the emails in order, remember, order by email, right? And if we want to see the emails in order and we want to see the usernames associated with each, I guess, no, order by email. Yeah, this actually works better, yeah. Yeah, I mean, this order by is only going to work really nicely for you if you only need one at a time here if you're not really dealing with groupings. But since we're dealing with a table where all these columns are unique, we're only going to be dealing with one order by parameter at a time. So it definitely did generate these nice unique IDs for us. I wonder, since now I have this table of users, I wonder if I could join this on this plant table, right? So maybe I could do like I could do something simple to show like just how joins works, right? So select plant name. u.id, u.username from plant sales. Join users on p.id equals u.id, right? ID. So let's see if we can get a join of a user ID with an ID of a transaction. Sort of silly because the sales in our plant sales are not really associated. We never really initially had it as a thing with the user table, but just to show how a join query visually looks, we could try to run this. And I think I called that. Let's look at the plant sales table again. What is this column called? Yeah, it is called plant name. I wasn't really sure exactly what the plant name column was called, but it is called plant name. Let's run this. Right, so we're seeing a join of like a lot of these since we created both of these so close in time together. But these are all the instances when an ID from the users table and an ID from the plants table were the same, and because they were the same, we were able to pull the plant name and the username together. So I think that's pretty cool. Another statement in SQL is union. And a union is like stacking like columns on top of each other. Right, so what does that mean? So select, let's say, yeah, let's do plant name again. So plant name, then username. No, select plant name, and yeah, store name. Store name, right? From plant sales. Union select. Username. Let's just do username and email from users. Plant name, store name, store underscore name. Okay. So this is a union clause where I'm going to try to stack the plant name columns and the store name columns on top of the username column information and the email column from users. Let's run this. Right, so this information doesn't make a whole lot of sense, but I'm just simply showing the SQL queries and stuff and how they work. So this is what it would look like if we just stack the information on top of each other. I'm not exactly sure how it's coming up with this order here, but it is zipping together these two tables. See what happens if we do order by username, plant name. Let's see what happens if we try to order this. Username does not exist. There's a column named username. So let's try to order by plant name. Okay, so it's going to make a good faith effort to order the plant names. Sure. So I'm going to go back to the plant sales table. Let's try to show some more queries we can do on the plant sales. Select start from plant sales. Alright, so let's say we wanted to get the average price. And remember, this plant sales table is like a table of all the plant sales transactions we've had, right? So transaction ID of 1, they bought this plant name at this store at that price. So let's try to get the average price. What we can do is, these are called aggregate functions. From plant sales, right? Select average price. So that's our average price. And you see how many decimals it has. We can cast it to an int if we wanted to make it look cooler. If we cast it to float, I don't think it's going to do anything. So let's say we wanted to round it to 2 decimal places to look more like a normal price. We do round this, put it in parentheses, comma, give it an argument of 2, right, to 2 decimal places. Ooh, that's not working. Oh, I spelled it wrong. Huh. That's funny. Let's try that again. Okay. So that's how we can round it to 2 decimal places, and that's important to know for when you're dealing with like prices and stuff, because generally, you know, people in the world, we understand it as being to 2 decimal places. Let's try to select the lowest, or let's try to set, okay, we're going to try to select the second highest sale from plant sales, right? So first let's just show selecting the highest sale, right? So we can do like select star from plant sales, order by price descending, limit 1 to just see the top, to just pick off the top row, right? So at ID of 18 we got the highest sale, right? Now let's say there was another sale at $75, right? So let's do limit 2. All right, so we're a little bit lucky that the second highest was 73. So what we could do is, I mean, we could do this to select the second highest. We could do select star from this, right? Select all from this query we just made. Order by price. Let's say, yeah, order by price descending, right? Limit. No, we want to order it by price. Yeah, we want to order by price limit 1, right? I mean, this is a cheeky way where we can just pick off, where we can get the second row here, right? So let's start from here. Right, see, now we just selected the second highest sale from plant sales. I think there's another cool way of doing it where we can select a row not in the top row. Okay, so we're going to go back to our original query here, and we're going to try to select rows that are not in another query. So in this query, we know that this row of data would have the highest price. So we want to select star from plant sales. And we want to adjust this subquery here so it's only showing the price. Select star from plant sales where price not in this query here. Order by price descending, limit 1. Okay, so we want to select all from plant sales where the price is not among the highest price, which we got here, right? There we go. And I ran it, and there we go. That's our second highest price. 73. Similar idea to what we did before. But that's how you can go one step beyond like just your normal, select max. Now you can go a step further and like select the third highest or select the top 5. Right, so let's say we wanted to select top 5 sales. We could do like select star from plant sales, order by price descending, limit 5, right? We only want 5 rows. Now we have a duplicate here. Let's say we wanted the 5. Select 5. Yeah, that wouldn't make a whole lot of sense. I want to select the distinct. Right? Select the top 5 sales. Select the top 5 transactions where the price was in the top 5 price. So that would be a more interesting query to do. So maybe we can add a ranking to each price, right? So we could do like select star and then rank. Maybe we're doing the dense rank, right? We're doing the dense rank over order by price descending as are from plant sales. see how that works. Okay, so we see our top one is 75, that's the ranking of 1. Then we go down to our second one, 2, 3, and then these are tied for 4th, right? And then 5. So if we wanted the 5 transactions where the price was within the top 5 of price, right? We would do, what if we just did limit 5 here? Limit, no, that wouldn't work. I wonder if having R less than 6, let's see if this will work. No, it doesn't like that. Where R is less than 6. Let's try that. No, we have to go a little bit more nuanced than that. So we're going to select start from here. Let's get rid of this so it's not confusing. So select start from this query. Okay. Alright, so these are all the transactions where the price is within the top 5 prices. Plant name, store name. Just to clean it up. Let's say we want this ordered by ID, right? Ordered by ID. Now they're ordered by ID, but now the price is different. So I think that is pretty cool. Now what if so let's say this is the biggest sale here, right? Let's say I wanted to amend this table, alter values in this table we already have. So this price is 75. Let's say I wanted to make this 100. Let's say that person really actually didn't pay 75. Let's say they really paid $100. Update, I think we just have to do plant sales. Set price equals 100 where ID equals 18, right? That's this row here. The ID is 18. Select star from plant house. Select star from plant sales. Order by price descending. See, now it's at 100. So yeah, that's how you can go in there into an SQL table and update, change stuff. You can even get more creative. So we set price equals this, but we could be like, I think we can actually put a query in here also. So maybe we could be like, let's set it to the lowest price, or let's set it to the average price. Select price equals select average price from plant sales. right? Now let's go to our ID of 18 again. See, now we altered it. It was at 100, now we changed it to 41, which is the average price. And it's also nice that it looks like it's in the center here, right? Generally where averages are, they're in the center. So yeah, let's say we wanted to get the difference, right? Get the difference between the highest price and lowest price, right? We can do this, right? We can combine, we can do arithmetic with these aggregates also. Minus min price from plant sales. Let's call this, let's alias it as diff. We're going to call this column diff. So that's the difference between the biggest price and the lowest price, 67. I think another thing that we can do is you can add conditionals into your aggregates as well, these case statements. So let's select the sum of transactions where the price was, let's say, where the price was even, right? So where there was an even price, let's sum all the prices of that. Okay, so we can do select star from plant sales. And we're going to get more specific. We want the sum. Let's just select the sum. Let's sum case when price modulo 2 is 0, then price, else 0. End. You have to end the statement. So when we run into a price where the modulo of 2 is 0, we know it's an even value, right? So if it's even, then we want to see that price. Else, we're just going to sum up the values of 0, which is nothing. We're going to alias this as called evens. That's funny, 420. So the sum is 420. And let's just see those actual columns and rows, or let's see the rows of data. It actually did add up. Select ID, price. Actually, we could just copy and paste this. Yeah, just copy and paste this. Select ID. From plant cells. Where evens is not null. Choo, that don't work. Okay. Let's just run this. So these were all the transactions where the price was an even number. And I forget because I had brain freeze. How do I query this but just ignore the... let's see, select star, select this. Let's see, case when where price yeah, so we're just going to do select ID and price from this table. We're going to cut this. I'm going to paste this on the other end of this. Where the modulo is 0, right? Select ID and price from plant sales, where price modulo 2 is 0. There we go. That's how we get rid of those null values. And then apparently when you add all this up, it equals 420, right? Select sum price from this subquery here. And it should equal 420. Sum is 420. So yeah, I think that's pretty cool stuff. I want to quickly show the group by. So before I was doing what's called a window function. These are called window functions. And it's just another way of saying group bys. They're just different ways of writing group functions, groupings. Select star from plant cells. Now let's think of a group by query we can come up with. Maybe what we could do is we can select the store name. Let's write this down. Select distinct store names and their associated average price, right? I think you get the idea. So we're going to select the store names and the average price that they're selling stuff at. And we have four different store names, right? So we should get ultimately 4 rows of information. The 4 different store names and the average associated with each store name. I think we could start this with select store name, average price from plant sales. Group by store name and price. Let's see if we just do store name. We're just grouping it by store name and then getting the average price over the store name, right? There we go. That's the average price for those. We can order this by order by store name. Okay, so store A So maybe you'll be asked someday, like, hey, find me the store, give me the store name and the average price of the store with the highest average. So we want to return store C, right? So let's say well, let's say, what if we had two stores that had the same average price, right? Let's say they were ties. So maybe that ranking window function would be useful. We could select star, dense rank over order by average from this table, from this query. Call it R. Order by average descending, right? We want the top ones. So now we want to select the one with an R of 1. Grr, that don't work. Okay, so we're going to select star from this. R equals 1, right? So that's our store name and the average price at that store of the highest. This is the store with the highest average price, which was store C. Now let's just add some context to this. Order by store name, right? So if I had asked you at first to see all the information grouped by the store name, right? It's hard just by looking at this to see which store has the highest average price, right? It's hard to do just by looking at it. That's one reason why I went into Mockito and asked for it to generate 30 rows of data. So it's hard just by looking at it to see. However, if we exploit the SQL and make a query, we can get the precise math, and we can actually see a nice, tidier representation, and then see the actual information we want to see, right? So that's how we can quickly see the highest average. So yeah, I hope you picked up some stuff there about how SQL works. And now that I think about it, I actually did show you how to alter and create a table. Let's just quickly show how to delete stuff, right? Select star from plant cells, right? So let's say I wanted to delete all the information from store C, right? Let's say I don't want transactions that were done at store C in this table, right? This is store C, that's store C. So let's get rid of all the store C's. Delete from plant cells. Where store name equals store C. I think that's right. And then select star from plant cells. Oops. You can see our store C is gone. It's no longer in the table. So yeah, I showed you create, update, delete. there's another thing called drop table, and there's also my favorite, which is truncate table, I think, right? Truncate table. So if I run this query truncate table, it's actually going to erase all the information within plant cells, but it's not going to delete the table plant cells, right? See, our table is still here, it's just now the information is just deleted from it, it's just erased. However, if I insert data again back into the table, and then query the data, you see the ID is 31. So it's always serialized. It's always going to increment the ID for us, and it helps with normalization. It helps with not having duplicate IDs. So yeah, I hope you like that content. Hopefully you'll get a better grasp on SQL. I recommend using Stratus, Scratch, or LeetCode to help you with getting sharper, help you with solving SQL puzzles. If you like this content, please like and subscribe, and happy coding.